The following scenario is hypothetical and presented for educational and entertainment purposes. Part 1. The Visitor Without Light. In our world, so similar to yours yet unraveled by different constants, the sky did not announce the catastrophe. There was no blazing comet, no gravitational siren screaming through telescopes. The intruder arrived invisibly, as black holes always do. Not as objects one sees, but as absences one calculates. The first anomaly was recorded not by astronomers, but by miners in the Atacama depth array. Seismographs registered a tremor that was too symmetrical to be tectonic. It began in the upper atmosphere and ended in the mantle less than a second later, a vertical puncture through Earth's layered anatomy. A straight line, no fault lines curve so obediently. In your universe, a black hole the mass of a mountain would be unimaginably dense, compressed beyond neutron degeneracy, its Schwarzschild radius barely the size of a grain of sand. In ours, gravitational constants differ slightly, allowing micro-black holes to persist far longer than Hawking radiation would permit in your physics. And so it came. A relic from primordial turbulence, wandering through interstellar dark like a forgotten seed. It entered Earth at nearly 200 kilometers per second. The atmosphere barely resisted. Air molecules were gravitationally focused toward the intruder's path, heating into a filament of plasma brighter than lightning, but thinner than a needle. Satellites registered a vertical flash, too straight for a meteor, too fast for re-entry debris. Before algorithms could classify it, the black hole had already penetrated the crust. Here's the counterintuitive truth. Earth did not shatter. A small black hole does not suck like a cosmic vacuum cleaner. Its gravitational influence is severe, but extremely localized. Most of the planet's mass never noticed its passage. The hole's event horizon, perhaps a few millimeters wide in our altered constants, interacted only with material in its immediate vicinity. Matter that wandered too close was swallowed, adding infinitesimally to its mass. The majority was not consumed, but violently displaced. As it bored through granite, basalt, and iron, tidal forces stretched nearby matter into streams, compressing it behind into a shockwave. Temperatures along the track exceeded those at the sun's core. Rock liquefied instantly, then vaporized. A column of superheated plasma punched downward, chasing the singularity like a comet tail made of Earth itself. When it emerged from the planet's far side, it left behind a tunnel no wider than a city subway line, but extending from crust to crust, a planetary biopsy. Magma flooded inward from both ends. Oceans above the exit site frothed as if boiled from below. In less than 3 seconds, the black hole was gone, continuing its silent transit into space. And yet, what remained inside Earth was far more dangerous than the visitor itself, because the hole had not merely passed through, it had slowed, just slightly. Not enough to escape Earth's gravity entirely, not enough to avoid coming back. Part 2, the second impact. In our calculations, the margin between escape and imprisonment is razor thin. When the black hole pierced Earth the first time, it lost kinetic energy, not through friction in the conventional sense, but through gravitational drag. As it plowed through dense matter, it gravitationally scattered atoms sideways, transferring momentum into shock waves and heat. Each interaction was minuscule. Collectively, across 12,700 kilometers of planetary diameter, it was decisive. The object that had entered on a hyperbolic trajectory now followed a bound orbit. For 43 minutes, it traveled outward through space, slowed by Earth's gravity well. Then it stopped and fell back. The second entry was not symmetrical. This time, the black hole did not approach at a clean perpendicular angle. Earth had rotated. The previous exit wound was no longer aligned. The re-entry occurred beneath the Pacific Basin, angled toward the equator. The ocean did not explode in a cinematic plume. Instead, something stranger happened. Water along the projected path was gravitationally accelerated inward, collapsing toward an invisible axis. For a fraction of a second, a narrow vertical cavity formed in the sea, a void carved by space-time curvature itself. Then the surrounding water crashed inward with supersonic fury. The resulting shockwave propagated outward as a ring, not unlike the ripples from a stone dropped into a pond, but scaled to continental dimensions. Tsunami warnings triggered too late. As the singularity pierced the oceanic crust, it passed through sediment and basalt, once again carving a plasma-lined tunnel. But this time, the planet responded differently. The first transit had weakened structural equilibria deep within the mantle. Convection currents, those slow, churning rivers of rock that regulate tectonic plates, were disrupted by the initial thermal column. The second passage intersected partially molten regions destabilized only an hour before. The result was the first major climax of our crisis. Mantle plumes erupted along the black hole's track like beads on a wire. Volcanoes ignited in synchrony across thousands of kilometers. In Indonesia, in Chile, in Iceland, geometrically aligned along a line no natural tectonic model could explain, eruptions began within minutes of one another. Seismographs drew a straight scar across the globe. Inside Earth's core, something even more profound occurred. As the black hole transited the outer core, a convective ocean of liquid iron responsible for generating Earth's magnetic field, it created turbulence on a scale never recorded. The geodynamo relies on delicate rotational and thermal balances. The passage of a compact mass, even one only the mass of Everest compressed into millimeters, introduced asymmetry into that flow. Within hours, satellites detected fluctuations in the magnetosphere. Auroras bloomed at equatorial latitudes. Charged particles from the solar wind, once guided safely toward polar regions, began penetrating deeper into the atmosphere. Civilization noticed now. Power grids failed in cascading patterns. High-frequency communications dissolved into static. Navigation satellites drifted off calibration. Yet the public explanation, unusual solar activity, was a comforting lie. The sun was calm. The disturbance came from below. Meanwhile, deep beneath the crust, the black hole reached apogee once more, this time not escaping as far. Each transit bled more energy. Each oscillation through Earth shortened its arc. Orbital models converged on a terrifying conclusion. The singularity was no longer merely passing through. It was settling in. Part 3. The heart that should not exist. By the third transit, the question was no longer whether the black hole would return. It was how many times it already had. The oscillation period shortened from 43 minutes to 38, then to 31. Each passage was no longer a clean perforation from crust to crust. The trajectory began curving inward, precessing like a dying pendulum. Earth's gravity was winning. The singularity's orbit was decaying, and with every plunge, it deposited heat. To understand the danger, you must understand something fundamental about planetary stability. Earth is not a rigid sphere, it is a thermodynamic engine. Heat flows outward from radioactive decay and residual formation energy. Convection in the mantle regulates plate tectonics. The outer core's motion sustains the magnetic field. These systems are balanced by gradients: temperature, density, rotation. The black hole introduced a new gradient. Each transit generated a column of extreme heating along its path. Rock did not merely melt, it ionized. Surrounding matter, gravitationally compressed and sheared by tidal forces, converted gravitational potential energy directly into thermal energy. Though the event horizon was tiny, the sphere of influence, where tidal differentials were strong enough to fracture and accelerate matter, extended kilometers outward. By the fifth oscillation, a permanent molten conduit had formed along the average trajectory. Magma from disparate mantle reservoirs began mixing unnaturally. Seismic tomography revealed something unprecedented, a vertical river of low-density plasma-like material linking crust and core. Then came the second major climax. During what scientists believed would be the seventh transit, the black hole did not reemerge. Seismographs recorded entry. Oceans convulsed. The atmosphere ionized in a luminous filament. But there was no exit event on the opposite hemisphere. No plasma bloom. No shockwave. Only silence. Deep within the planet, the singularity had reached terminal velocity relative to the surrounding medium. Its orbit had decayed below escape symmetry. Instead of oscillating outward, it spiraled inward, losing angular momentum through gravitational interactions with dense core material. It was captured. Contrary to apocalyptic intuition, Earth did not implode instantly. A black hole does not devour a planet like a starving beast. Accretion is limited by cross-sectional area and available inflow. The event horizon remained minuscule. Matter had to wander very close to be consumed, but now at Earth's center it no longer passed quickly. It lingered. Surrounding iron and nickel began to form an accretion envelope. As matter spiraled inward, it accelerated, heating through viscous and compressive forces. The process released energy, immense energy, radiating outward as high-energy neutrinos and gamma bursts trapped within kilometers of rock. The core's temperature rose measurably. Convection patterns destabilized entirely. The magnetic field flickered erratically, collapsing to 20% of its normal strength in less than a week. Radiation belts expanded. Satellites died in droves. On the surface, animals that relied on geomagnetic navigation, birds, whales, even bacteria, became disoriented. But the most disturbing data came from gravitational observatories. Earth's moment of inertia was changing. Mass was redistributing toward the center, not only because of accretion, but because surrounding material, heated and partially fluidized, flowed inward. The planet was becoming slightly more compact, days shortened by milliseconds, not from tectonic shifts, from gravitational contraction. And in underground laboratories shielded beneath kilometers of rock, physicists reached the same conclusion simultaneously. If accretion continued at the accelerating rate they were measuring, Earth would not be swallowed. It would ignite. Part 4. The slow fire ignition did not mean explosion. That misunderstanding nearly doomed our species. When the models first projected core ignition, politicians imagined planetary detonation, continents vaporized, oceans blasted into space. But the equations told a subtler, more terrifying story. The black hole at Earth's center was not large enough to consume the planet rapidly. Its event horizon remained microscopic. What grew instead was the accretion luminosity. Matter falling inward does not disappear quietly. As iron and nickel spiraled toward the singularity, gravitational potential energy converted into heat with near-perfect efficiency. In astrophysical systems, around neutron stars or stellar black holes, this process can outshine entire galaxies. Scaled to Earth, it became a hidden furnace. The core temperature rose by hundreds of degrees per week. Normally, Earth sheds internal heat gradually through mantle convection and volcanic outgassing. But now the energy input exceeded the output. The mantle's viscosity dropped as it warmed, accelerating convection into violent overturns. Superplumes, columns of buoyant magma hundreds of kilometers wide, punched upward through weakened lithosphere. Volcanic activity became global and synchronous. The atmosphere thickened with sulfur dioxide and ash. Sunlight dimmed. Paradoxically, surface temperatures first fell under volcanic winter conditions. Crops failed within a single growing season. Power grids, already crippled by magnetic instability, collapsed permanently as geomagnetic shielding dwindled further. For the magnetosphere was dying. The outer core's convection had become chaotic. Instead of coherent rotational flow generating a stable dipole field, turbulent eddies dominated. The magnetic poles wandered kilometers per day. Auroras engulfed entire hemispheres. Solar radiation began stripping upper atmospheric layers at measurable rates. Yet the planet did not tear itself apart. Instead, it transformed. As central mass concentration increased, Earth's radius contracted by centimeters, then meters over months. Gravitational binding energy released during contraction added further heating, a feedback loop compounding the black hole's accretion output. Day length shortened again. Tidal interactions with the moon intensified, altering ocean circulation patterns, and still the singularity remained small. Why? Because accretion in dense environments becomes self-regulating. As material near the core heated, pressure gradients formed that partially resisted further inward flow. A quasi-equilibrium developed. Matter fell in, energy radiated outward through conduction and convection, and the planet adjusted structurally. Earth was not being eaten. It was becoming something else. Deep mantle minerals, subjected to rising pressures and temperatures, transitioned into exotic, high-density phases previously achievable only in laboratory shock experiments. The inner core expanded as surrounding layers compressed. Seismic wave velocities changed so dramatically that old geological models became obsolete within months. Human civilization did not survive the transition intact. Coastal cities drowned under mega tsunamis triggered by tectonic reconfiguration. Agricultural belts shifted unpredictably. Radiation exposure increased cancer rates worldwide. Billions perished, not from a single cataclysm, but from cascading systemic collapse. And then, after decades, stabilization emerged. The black hole remained at the center, but accretion slowed dramatically as nearby matter settled into a dense, high-pressure equilibrium shell. The geomagnetic field reestablished itself, not identical to the old dipole, but stronger. fueled by intensified rotational gradients from the planet's slightly reduced radius. Volcanism subsided into a new normal. The atmosphere, replenished by outgassing, grew thicker and richer in greenhouse gases. Surface temperatures climbed beyond their former averages, melting polar ice permanently. New oceans formed over reshaped continents. Earth had survived, not as the world it was, but as a denser, hotter, magnetically volatile planet with a singularity at its heart. A world internally powered not only by radioactive decay, but by a captive relic of cosmic infancy. In our universe, we do not call it apocalypse, we call it the second formation. Because the greatest scientific revelation was not that a small black hole could destroy a planet, it was that, under the right conditions, it could remake one.